Sorry for the break in transmission. So now let's go to velocity time graph now. So for velocity time graph, we have let's draw the graphs, all the graphs. So we start with this, this, this. So also something like this. Okay. You know what you have on this side already. That'll be V with a mark. See, V with a dash on top. See, V with a dash on top. See, a V with a dash on top. See. Now for each. Now let's start with the what's the area, the slope, and how it represent first. Now the slope of this graph will be what? Change in velocity. Change velocity over time. Now what does change velocity over time represents? Change velocity over time represents what? Your acceleration. So that means that your slope, the slope of your velocity time graph is what? Is acceleration. Take note. The slope of your velocity time graph is what? Is acceleration. Now let's go to the area. Now the area will be what? Velocity times time. Now your velocity times time will give you what? Velocity times time will represent what exactly? It represents what? Your displacement. But don't forget that the formula of calculating velocity is what? Change in displacement over time. So that means making velocity times time, sorry, the formula, you're going to have what? Velocity times time equals what? Change in displacement. That's what total displacement what? Covered. I hope you get to the area of your velocity time graph is what? Is your total displacement. Why your slope is what? Is what? Your acceleration. Now let's talk about each of these graphs. Let's interpret each of these graphs before we move to that of what? The last one is the acceleration. And also it's very important for you to note that the graph that gives the most details, the graphs that gives the most, now from velocity time graph also you can also know the velocity at a particular point in time. So the graphs that gives the most details is your velocity time graph. Take note. The velocity time graph gives the most details because looking at it, you know, your velocity time graph can be used to determine your velocity at a particular point in time, your total displacement, your acceleration. I forget all like close like three compared to all others that they always give you just one information or two. This one's giving you three information, so it's the most details. It gives you the most details. Okay. So now for the first graph now, this shows that what is your velocity what remains constant. That means your velocity is what is uniform. And then for velocity to be uniform, that means your acceleration, which is your slope now, is what is zero, because in order for there to be acceleration, there has to be what change in velocity. And since there is no change in velocity, that means what the acceleration, there is zero acceleration. Acceleration is constant. Is not constant. Acceleration is zero. To make it up, acceleration is zero because there is no change in velocity. It's like you're saying the stuff remains at 5 or true. So when you want to look at it, you'll be like 5 minus 5 is what? Zero. All over the time. Anything divided by zero is what? Is zero. Okay, now moving on to the second one. Now, but then you can calculate the area under the graph now. This area will give you what? Your total displacement, which you can also use to represent your distance, because here it is not showing your total displacement or your total distance. Use to represent your total distance, because thinking about it, there are some graphs that they will move towards the negative side because you're doing the velocity now, and the velocity has directions, and because of the direction that it has, it tends to have a negative value sometimes, just to indicate the direction. So when you're not doing the maths, you're doing the calculation, you might get negative sign that might negate another one, so that you really get a positive value. Although I think there are some times that you get negative values, but then just stick to total displacement. let's just teach you when you solve questions, then you be able to like balance the whole equation from there. Now for the next graph now, this graph means that velocity is increasing with time, like it's increasing constantly with time. So that means what? Your velocity is not constant. Your velocity is not constant. Your velocity is what? Is increasing. But then your velocity is your change in velocity with time is the one that is constant. Please don't mix it up. The velocity itself is not constant. It is increasing. It's increasing upwards. But then the change in velocity at every point in time is the one that is constant. And for the change in velocity to be constant, don't forget that your acceleration is equal to a change in velocity over time. So that means you can say that your acceleration is proportional to change in velocity. So that means that anything that is happening to your change in velocity will happen to your acceleration. Anything that is happening to your acceleration will happen to your change in velocity. So that means your acceleration is, since your velocity is constantly changing, since your change in velocity is constant, since your change in velocity is constant, that means your acceleration will also be what? Constant. So for this graph, your velocity is not constant, it is increasing, but then your change in velocity is what? Is constant, and your acceleration is also what? Is also constant. Now for the next graph, you notice that something was a little bit curve. All this represent it. I can't remember the name again. That's an exponential. I think it's this last one that's exponential. Now for this graph, you notice that initially the velocity was now throughout the whole journey, the velocity was increasing till it got to a point that it was constant. And then you know observe that around this point, the rate of increase of the velocity is faster. So that means initially the object was accelerating because the change in velocity at that point was greater. Then it gets to a point it starts reducing its acceleration. That's basically the way you interpret it. So basically, just to interpret this graph, just look for, you already know what the slope represents. You already know what the area represents. Just look for, try and observe. The steeper the slope, the greater the slope. Like the steeper the slope, like the steeper it is, like the more to the vertical that it is, the the greater the slope. So that means if you have a very steep slope, that means the value that you most likely get when you calculate the slope will be very, very huge. That's basically what it means. That's basically the way you interpret it. Why for this last part, the stuff is what is in the opposite direction is negative. So that means you, in this case, you have what? Deceleration, not acceleration. Hope you get. And then the acceleration is not even constant. It's always changing because the stuff is curve. I mean, it was like a straight line now. Like we have said that the acceleration is constant, and that in that case is what? Constant deceleration. But then it's not constant, it's changing as well. So that's that for velocity time graph. Now let's go to acceleration time graph. So now you're going to have acceleration time, acceleration time, acceleration time, acceleration time. Let's now talk about the slope and the area. That's what you always think about first when you have a graph. What is the slope? What is the area? That will help with the interpretation of that graph. Now the slope of this graph now is what? Acceleration over time. Is there anything like acceleration over time anywhere? No. So that means what? Your slope of this graph is what? Is nothing. It's very useless. And then you now go ahead to the area, and the area will be what? Acceleration times time. Acceleration times time will give you what? Will give you what? Your velocity. Why? Because you have acceleration to be equal to what? Change in velocity over time. So when you make acceleration times time, so your formula in this case, you are going to get what? Your change in velocity. So that means your area for this graph is what? Change in velocity. The area under the graph is what? represent your change in velocity. Let's now go to each individual graphs. So we have this. Mm. Now, what this represents is that what acceleration is what is constant. Your acceleration is what is constant, all true. And when you calculate the area under the graph, it should mean what this also means is for the acceleration to be constant. Oh, there's not even relationship with it with change in velocity because you can't really know for the acceleration to be constant. That means the velocity is changing. So obviously you know that the velocity can never be constant. It's changing. Probably the change in the velocity now. You know that you can answer okay, yeah, the change in velocity is constant, which is the area under the graph. Now, for the second graph, the acceleration is what is not constant, it is increasing, but then the increase in the acceleration is what is one that is constant. Now, for the third, the acceleration is not constant, it is increasing, but then the change in acceleration is one that is what no, the acceleration is not constant, the change in acceleration is also not constant, it's decreasing. And then for this last part, the acceleration is what is decreasing. For this last graph, we have acceleration to be what to be decreasing. So those are the graphs. Those are what you need to understand, like all the graphs that you need to understand before we actually jump into like motion proper. Now let's not talk about motion proper. Since you already understand some of the formulas, like you know that for to calculate your speed now. You know that to calculate your speed, it will give you what your velocity. So what am I saying? Give you a display. Your speed is distance over time. Your velocity is displacement over time. The acceleration is now what change in velocity over time. Now you can obviously change the soluble formula of all these. You can change the formula of all these equations, so that you might make displacement of the formula. You can even go ahead to make times of the formula anyone you like. Okay, so let me give you some of those different stuff. So when we start talking about equation for uniform motion, you understand it better. So let's start with the way I can make this thinner. Okay, you have v to be velocity. Oh, let's say speed. Speed to be equals to distance. Oh, what am I doing again? Now you have our distance to be equal to speed times time. We have our displacement to be equal to velocity times time. We have our acceleration to be equal to no acceleration now. We have our change velocity to be equal to acceleration times time. What else? Okay, I think those are you can basically just change the sort of formula for each of these equations. So with that said, now let's go to equation for of uniform motion. Now we have 4 of them, but then most textbooks will give you 3. Now the first is v. The first is v equals ut plus at. The second is s equals to ut plus half at squared. The third is s equals to u plus v all over 2 times t, while the last is v square equals u square plus 2as. Now you know what each of this stuff represents. Your V there is what your final velocity, your U there is what your initial velocity, your A there is what your acceleration, your T there is your time, your S there is what your distance. What else? So that's all. Now you need to know this formula. Although you know you can obviously derive some of this formula yourself. Once you already know the formula for calculating each of those, like your average velocity now, your average velocity, formula for calculating average velocity is 1 over 2, 1 over 2 times the summation of the two velocity or the two speeds that you have, depending on whether you're looking for average velocity or average time or average speed. Sorry. So you can obviously derive this, but then for to save time, it's something you can know yourself. For example, for the first one now, the formula for calculating acceleration is v minus u all over t. Yes. So when you make v sort of formula, you're going to get u plus at. Yeah, I want to get u plus at. Now for the second one, that's where it might get a little bit tricky because I think that you're going to now start substituting another content, but then so as not to waste time, just do this formula offhand. Like it's something you can easily know. V equals to u plus at, s equals to ut plus rvat squared, s equals to u plus v all over 2 times t. This second one is the one they use to calculate average velocity, because you notice that your average velocity is what u plus v over 2, or average speed, average speed is u plus 2 over 2. Basically what you just did here is just use the average to calculate what the total distance covered, which is the s there. That's all. So once you know that, and then for the last one, b square equals to u square plus 2s. It's basically something you can know, because you can obviously start deriving it in the example. Just know it as it is. Now, don't forget that I mentioned before that these are the equation of uniform motion. So there's a particular criteria that you must notice, that you must see before you use these formulas. And that criteria is that what the acceleration must be constant. If the acceleration is not constant, this formula will not work for whatever you are using it for. The acceleration of that particular equation must be constant. Acceleration must be constant. If acceleration is not constant, you go and use it. You don't enter. Don't use it unless you have your acceleration to be constant. So that's the criteria to use, that you need to like note before you actually use this particular formula. So just know this formula offhand, and basically once you solve a lot of questions, you won't need to start cramming these things. It naturally comes, because once you solve a lot of questions, you use it multiple times, you'll be able to like easily remember it. So that's that for equations of uniform motion. And when you attempt questions in class, well, let me give you an approach. Let me give you an approach to using this. Let me give you an approach to using this. Okay. Let me see. Okay. Let's start with this now. Instantaneous velocity, as I said before. That's that. I'm looking for questions. Okay, now the question says, oh, the velocity of a moving particule. Okay, this is when you are representing this stuff in terms of what do you call it? Something about integration. Something about integration and what's the other? What's the inverse of it? Integration and differentiation. Integration and differentiation. Okay. But then this for positive. Okay, now these are the equations for uniform motion. I said I'm looking for questions to just use to explain it better. Oh, they didn't have use any questions here. Wow. Just wow. Let me just form the question. Sorry, so that will be fun. But then you obviously have a question that you practice shortly after watching this video. So let's say a boy. I won't use a boy. I'll just use some of this material, some of this criteria. even though using a question like using a boy shouldn't come will have helped you with like knowing how to interpret it, but we are obviously going to solve questions. We want to do corrections some of those questions, and let's say a boy a boy who was initially stationary s- started moving at a velocity started moving at a velocity of started moving at a velocity of 20 meter per second. Oh no, let me use that. Okay, a boy with an initial velocity of 0. Oh no, let's complicate it a bit. A ball with an initial velocity of um of 2 meter per second cover the distance, cover the total distance of what of 20 meter in in 2 seconds, okay, in 5 seconds. In 5 seconds. Even I say okay, calculate the acceleration of the boy. Calculate the acceleration of the boy. So now in this question, so we are looking for acceleration. Now here we have. So what I always tend to tell people when they are trying to solve any question at all is you write down all the parameters. After writing down the parameters, you write down the parameters you are looking for as well. So then you just look for the formula that allows you to like fit each and every one of them into that particular formula. So you have USTA, which formula has all these, and that should be S equals UT plus half AT squared. Do you get? Then with this now you cannot put in all these parameters 220. Okay, so you now have S, which is what 20, U, which is 2, the time is 5, oh, plus half your A is the one you're looking for, then times 5 squared also. So now you have 20 minus 10 equals half A times your T is 5 squared, so that will be 25. So you have 10 equals half of 25 will give you what 12.5 A. So you make A 12. So from now you have A equals to what 10 over 12.5. Do you get? So that's basically the way you actually approach questions using this. You just you already know the formula of an, then you just write down you interpret the questions, you write down the formula, and then you slot in all your values, and then you get your answer. So see you guys in the next class or next video.